All right, guys, so this video focuses on Math 2150, Section 4.4. We're going to discuss properties of definite integrals, and we're going to look at two problems in this particular video. The first problem is going to discuss area between two curves, and I've given you an image of an example problem. Before I give you notes on that particular problem, let me give you some general notes, okay? So when we find the area between two curves, we're going to take the definite integral, still from a lower limit to an upper limit. So we have A and B. But let me write a little note here. A and B are intersection points. Okay, intersection X values. Okay. And then when you actually find the area between two curves, you're going to take the top function. So I'm just going to write the top and subtract the bottom function. Okay, so that's kind of the notes that I need to give you in general. So A and B represent intersection values. And when you actually take the integral, you're going to take the integral of the top minus the bottom. Okay, so let's take a look at the specific problem up here that I've given you. So I've written my integral symbol. If you take a look, and if I get my highlighter out, we intersect right here and we intersect right here. So this first point, guys, is clearly 0, 0. And the second point up here is already identified. It's 4, 4. And if you remember from the notes clearly say to take the x value. So the x value is 0, the other x value is 4. And so we're going to integrate from 0 to 4 in this particular problem, okay? Because when we're integrating with respect to x, okay? So we take a look at the x values. The top function is the curve. It's the pink function over here. And the curve is 5x minus x squared. And so we're going to start with 5x minus x squared. That's the top. Subtract the bottom. So this is the top. Subtract the bottom. The bottom is simply just x. And of course, put with respect to x. Okay? And so now if we clean it up a little bit, and we surely can, we'll come to the side. We're still going to go from 0 to 4. It's still going to be 5x minus x squared. We're going to minus x. All of that is with respect to x. And then, guys, you can simplify this. You've got 5x minus x. Those are like terms, so let me go again. If I come down here with it, that's going to be 0 to 4. 5x minus x is 4x minus x squared with respect to x. Okay, so we have simplified the integrand, and so now we're going to take the antiderivative. So if we take the antiderivative of 4x is 4x squared over 2. Minus the antiderivative of x squared is x cubed over 3. And we are integrating that from 0 to 4. And so I prefer to clean this up a little bit. You can already see the second problem down there at the bottom, but I'm going to clean this up. 4x squared over 2. 4 over 2 is just 2. So if I come down here on this line, this is just 2x squared minus x cubed over 3. And we are going to integrate that from 4 to 0. And hopefully you know that means everywhere we see an x, we're going to plug in a 4. So it's going to be 2 parentheses 4 squared minus 4 cubed over 3. And now everywhere we see a x, we're going to plug in a 0. So we say minus 2 times 0 squared minus 0 cubed over 3. Now let's do the math. 4 squared is 16. 16 times 2 is 32. 4 cubed is 64. 64 over 3. Minus 0 squared is 0 times 2 is 0 minus 0 cubed over 3. That's just a big old 0, guys. So really we're just looking at 32 minus 64 over 3. And guys, we do need to make a common denominator. So 32 is the same thing as 96 over 3 minus 64 over 3. And if I do that math in my head, 96 minus 64, hold on, that is going to be 32 over 3. And there's your answer, okay? So 32 over 3 is the answer to the first problem. And what did I simply do? I took intersection points and then subtracted the top minus the bottom and then continued the problem, okay? So there's one example. The second type of problem I wanted to look at is piecewise functions, okay? And this problem that I actually found online is a little bit more complicated than some that the notes give you or the PowerPoint lesson gives you, but we're going to get started with this one anyways, okay? So we are determining the interval from 0 to 8, and you can clearly see up here that we break at 3 and we break at 7, okay? So we're going to have to do several integrals for this. The first integral is going to be from 0 to 3. Why 3? Because it says x is less than 3 on the top line. That's going to be x squared dx. We're going to add. We're going to find the next integral. Well, the next integral says we can go from 3 to 7. So that's exactly where we're going to go, from 3 to 7. And that's going to be 12 minus x, again, with respect to x. And then the last integral, we're going to go from 7. And where the heck are we going to stop? Well, the problem tells us to stop at 8. So we're going to stop at 8. And that's just going to be 5 with respect to x. And guys, I hope you realize technically you have 3 problems here. Your first problem, your second problem, and your third problem. So if I was doing this in class with you, I would make you do literally 3 problems. First problem, 0 to 3 of x squared dx. When we integrate that, that's x cubed over 3 from 0 to 3. Plug in 3, so that'll be 3 cubed over 3. Subtract, plug in 0, 0 cubed over 3. Okay, so 3 cubed over 3 is 27 over 3, which will be 27 over 3, showing all work, minus 0 over 3. So your answer is just 27 over 3. Which simply equals 9. That is not your final answer. That is the answer to this very first integral, 9. We are now going to do integral number 2. Integral number 2 was from 3 to 7. 12 minus x with respect to x. So the integral of 12 is 12x minus x squared over 2. Integrating from 3 to 7. Well, you know that means everywhere you see an x, you're going to plug in a 7. And then everywhere you see an x, you're going to plug in a 3. Okay, so let's do it. 12 times 7 is 84. Minus 49 over 2. Minus 36, minus 9 over 2. 84 minus 49 over 2. Distribute your negative. Minus 36 plus 9 over 2. There you go. 84 minus 36. Let me come over here because I don't have a calculator. Minus 36. 48. So 84 minus 36 is 48. And negative 49 over 2 plus 9 over 2, because they have a common denominator, is negative 40 over 2. But you and I both know that negative 40 over 2 is actually 20. So we get an answer of 48 minus 20, which is 28. Okay, so if I come back up here, here's the area to piece 1. Here's the area of piece 2. And so the last one, we have to find the area of piece 3. And piece 3, if I come all the way up, was from 7 to 8 of 5. From 7 to 8, 5 dx. So the integral of 5 is 5x from 7 to 8. So you know that means plug in a 8. subtract, plug in a 7. So this is 40 minus 35, which simply equals 5. And so the area to the first problem, again, was 9, I think. Let me roll back up. Yep, 9. Plus the second area was 28. Plus the third area was 5. And if you add all that up, guys, 5 plus 28 is 33. And 33 plus 9 is 42. So your entire area is 42. Okay? So those are the two types of problems I wanted to look at. Thanks for listening.